Hey fellow problem solvers, ColfaxMath here. This is a Foundations of Math course. This course is a series of videos with an attached document that you work your way through to fill in any holes you might have in your math education. Math is actually not that hard. It only seems hard because it's so cumulative, meaning it's so based on the previous section. So this course is intended to kind of catch you up and bring you up to speed so all the future math will go forward easily. The only way to build a nice home is to have a solid foundation, and that is the exact same thing in this course right here with mathematics. So this is the 5th video in the series. This video is going to be ratio, proportion, rate problems, and unit conversions. The first 4 videos, video number 1 was whole numbers, and then the next 3 videos were really taking those numbers and breaking them apart. So fractions, decimals, and percents. So there's a link in the description to all the previous videos. I'd recommend you watch those to make sure those skills are solidified. I'll create a playlist of all these videos, and in the description as well, there's a link to this document. I'd print it out. I would actually do the problems before I do them with the video paused, and then do the problems, unpause the video, and then watch how I go through them. And hopefully you'll learn some tips and tricks and fill in some of those holes. The whole point of this video is to prepare you for a standardized math exam like the ASVAB for military entrance exam in math, or a union trade exam in math. So they're foundational skills that'll really carry a long way. So let's go ahead and get started. This video I'm going to go over ratio, proportions, rate problems, and unit conversions. The outcomes for this video and the paperwork attached to it is understanding ratios, putting ratios in their simplest forms, finding equivalent ratios, solving proportion problems, solving rate problems, and just a couple quick unit conversions. A ratio is a comparison of 2 numbers, like say men to women on a job site. It could also be ingredients, whether you're mixing concrete or cookies. It could be how much sand is in a yard of concrete. It could be the pitch of a roof. If you're looking at the pitch of a roof, the common ratio is rise over run. Let's say you rise 4 and you run 12. You could write it as 4 and 12. You could write it as a fraction, rise over run. You could write it 4 to 12, or you could write it 4 to 12 that way. All 3 ways to represent a ratio. Usually you reduce them, and roof pitch you don't, but you could reduce that to say 4 goes into there once, into there 3 times, so you could reduce it to 1/3. The units are usually the same in a ratio, like 4 feet to 12 feet, or 4 inches to 12 inches. So that's a ratio. Next is a proportion. A proportion is when you set one ratio equal to another ratio. Like here, let's say I have a half is equal to something over 10. Well, the way I would do that is I would say, how do I get from 2 to 10? Well, I would multiply by 5. So 1 times 5 would get me at 5. So the one ratio equal to another is a proportion, usually solving for one of the 4 pieces in there. And then a rate problem is a ratio where there are different units in the numerator and the denominator, like speed of a car, miles per hour, or like cost of a house, dollars per square foot, or how much mileage you get, how many miles per gallon you get on your car. So again, that's a rate. A proportion, one ratio equal to another ratio, and a ratio is just a comparison of 2 things with the same units. Okay, let's do some ratio problems right here. Express the comparison in simplest form. So I'm going to write that sentence 6 inches to 24 inches as a fraction. My inches are the same. They're going to cancel. 6 goes into 6 1 times, and 24 4 times. So that's the equivalent of a ratio 1 to 4. Another way to write it is with that colon like that. That's saying 4 to 32. I could reduce that because 4 goes into 32 8 times. So I could reduce that to 1 to 8. I could write it that way, or I could write it 1 to 8 that way. Number 3 here, another way to write it, 25 to 100. So I'm just going to write that as a fraction, 25 to 100. Reduce that fraction, 25 goes into 25 1 times, goes into 100 4 times. So that ratio reduces to that. Right? Here's a ratio problem number 4 as a word problem. A parking lot has a total of 60 spaces. 20 of the spaces are filled. What is the ratio of filled spaces to total spaces? So that's filled to total. So I'm going to just write it as 20 to 60. I could reduce that to 1/3. There's a second problem here. what is the ratio of filled spaces? So what is filled spaces to not filled spaces? Well, filled spaces is still a 20. Not filled is 60 minus a 20, 40. So 20 to 40, or reducing to 1/2. So you got to read pretty carefully to get what ratio they're looking for. And then from ratios, we'll move on to proportion. This is similar to the one I just showed you. How do I get from 4 to 20? Well, I multiply by 5. So how do I get from 1 times 5 here? And then I have 5/20. Those are equivalents. One ratio equal to another is a proportion. Let's look at the next one. How do I get from 5 to 40? I multiply by 8. So if I multiply from 8 this way, I need to go backwards that way. So I got to divide by 8. Right? The reverse of multiplication is division. So 16 divided by 8 is 2. And the check is 2/5. The equivalent of 16/40 is? Well, times 8 times 8. Yes, it is. All right, and here's another proportion. Let's say I have 3 to 5. I'll write it as a fraction. And I'll set it equal to x over 35. I could do 5 times 7 equals 35. So 3 times 7 equals 21. The other way to solve proportions as well is to cross multiply. Take that one times the lower left times the upper right. 5 times x is equal to that times that. Upper left to lower right, 105. Divide both sides by 5. And I can see that x is equal to 21. Okay, let's do one proportion word problem right here. I'm going to take that sentence and break it down into fractions, figuring out what fraction or what part of fraction I need to solve for. So all I'm going to do is just read through there and set up one ratio equal to another. I have 1 quart of jam, and I need 80 strawberries. So 80 strawberries equals 1 quart. How many strawberries? So how many, I don't know, how many strawberries to make 3 quarts of jam? And then 1 times 3 puts you here. So 80 times 3 gives you 240 strawberries. And then here's another problem. How many to make 2.5 quarts of jam? So I set up the same proportion. 1 quart is 80 strawberries. Now instead of 3 quarts, I have 2.5 quarts. How many strawberries? Well, I do 1 times 2.5 to get here. So 80 times 2.5 to get here. 80 times 2 is 160. A half is 40 more, or 200. So it takes 200 strawberries to make 2.5 quarts of jam. Okay, let's move on to rate problems. Let's look at number 9 here. The building of a new home costs $120 a square foot. So that's a fraction. The numerator is dollars, and the denominator is square feet. And that's why it's considered a rate, because the units are different. How much will it cost to build a 2,000 square foot house? Well, I just take that number, I multiply it by 2,000. It is square feet as well. Any integer like that is really that integer over 1 to make it a fraction. But I can see my units cancel, so square feet and square feet will cancel because they're in the top and the bottom. So I have 120 times 2,000, 240,000. And then the only units I have is dollars, and that's what I was asked to find. This idea of canceling units is really a big idea. When we get to the last few problems on unit changing, you'll see how we're going to keep doing that. Okay, I'm traveling at 60 miles per hour. Again, that's a rate because it's 60 in the numerator, or miles in the numerator, hours in the denominator, and I travel for 4 hours. So I'm going to just multiply that by the 4 hours. Again, my hours cancel. 60 times 4 is 240. The only units I have are miles, so I travel 240 miles. Okay, number 11, what is the gas mileage of a car in miles per gallon if it drives 500 miles? So it's driving 500 miles with 20 gallons of fuel. So I'm looking for miles per gallon, so I'm looking for a rate, and that's what I have, and that's what lets me know the miles go in the numerator. Then I divide by gallons, so the gallons are in the denominator. 500 divided by 20 is 25, and it's going to be miles per gallon. You can write it that way, miles per gallon, or 25 miles per gallon. 12 if you play 125 games in 5 seasons. So again, I'm going to set that up as a fraction, 125 games in 5 seasons. How many games do you play per season? So it wants games per season. So because it's asking for games per season, I can see I have it set up correctly. Games in the numerator, seasons in the denominator. 125 divided by 5 is 25. And I have 25 games per season. Okay, now I just have some unit conversions here. These are rate problems because I have 60 miles per hour and I want to convert it to feet per minute. Before I even start this, I see as distance over time. And I still want distance over time, just different units. So I can write that out as a fraction. 60 miles per is my line, hour. I can only multiply by 1 so as not to change the value of it. So I have to have the fraction with the same value in the numerator and the denominator. So this is a hard one if you're not from the US, but 1 mile is equal to 5,280 feet. So these things are the same. 5,280 feet equal 1 mile, so they have the same weight. And then I'm going to multiply it to get rid of the hours and get minutes. I know 1 hour is 60 minutes. So also this is a factor of 1. 1 hour, 60 minutes are the same, so it's not going to change the value. My hours will cancel. 1 in the numerator, 1 in the denominator. My miles will cancel, 1 above and 1 below. I want feet per minute, and the only units I have in the numerator is feet. The only units I have in the denominator are minutes, and that's what I want. Actually, 60 and 60 will also cancel. And I can see that I go 5,280 feet per minute. Okay, number 14, our last one, $300,000. So dollars in the numerator for a 2,000 square foot house. So this is square feet. And I want to know the cost per foot. So I want to just reduce this to cost per square foot. And the units are the same because I want my answer to be in dollars per square feet. And I already have dollars per square feet. So I just do 300 divided by 2,000. 3 of those zeros will cancel with 3 of those. 300 divided by 2 is 150. $150 per square foot. Okay, well, hopefully that helped explain ratio, proportion, some rate problems, and unit conversions. You go pretty far and make it more complicated, but it's a foundational course, so this is hopefully giving you the foundation to do more and more complex problems and build on those skill sets. If you're new to the channel, think about subscribing, and please comment below with any questions you have, or if there are any math concepts you'd like me to go over. Thank you for watching.